Okay, and the final question in this practice paper, we want to show that 3n plus 1 all squared minus 3n minus 1 all squared is a multiple of 4. So the first thing I'd try and do here is I'd expand these out and see what happens. 3n plus 1 squared, well that's 3n plus 1 times 3n plus 1. I can use my box method to do that, and that'll really help me. That's 9n squared plus 3n plus 3n plus 1. And then 3n minus 1 all squared is 9n squared minus 3n plus 1. Expanding either of those out, and if I tidy that up, that's 9n squared plus 6n plus 1, just collecting like terms, and that's 9n squared minus 6n plus 1. So expanding and collecting like terms, either of those would probably get us a u in that question. Now let's go back to the original expression we had, 3n plus 1 squared minus 3n minus 1 squared. Well, that must be the same as 9n squared plus 6n plus 1 minus 9n squared minus 6n plus 1. 9n squared plus 6n plus 1, let's keep that. Let's expand that minus sign across that, minus 9n squared plus 6n minus 1. Now I can see some things I can cancel out. 9n squared minus 9n squared, well that's 0. Plus 1 minus 1, that's 0. So I'm left with 3n plus 1 squared minus 3n minus 1 squared is the same as 6n plus 6n, or 12n. Now to show that it's a multiple of 4, okay, 12 times the number is 3 times 4 times the number. Okay, it's a multiple of 12. 12 is 3 times 4, so it must be a multiple of 4. If n's a positive integer, like we're told back here. So just expanding out, not getting caught up by this minus and minus sign, making sure we get that right, simplifying, and then we just go on to show that that's a multiple of 12. It's 12n, and which must be a multiple of 4, because 12 is a multiple of 4. And that's all we needed there for our excellence.